So I wanted to go through this calculation here on how to calculate the concentration of hydrochloric acid when hydrochloric acid reacts with sodium carbonate. From knowing the amount of hydrochloric acid, we can find the concentration. So this equation of this problem is where we have 500 centimeters cubed of an acid, so 500 centimeters cubed of 2 molar hydrochloric acid, and in there we've got 25 grams of sodium carbonate, and we're going to react that, and because it's a carbonate, it's going to give off a gas, it's going to give off carbon dioxide, and we're going to collect the carbon dioxide. Okay, so we'll be able to work out how much carbon dioxide comes off every number of seconds, and from that we can translate that to hydrochloric acid. So we can see here we've done the reaction, we've added sodium carbonate to hydrochloric acid, and we've collected gas. So at these different time intervals, this is the amount of gas we've collected. So we want to calculate the concentration of hydrochloric acid, and in order to do that we need to know how much hydrochloric acid we had at the beginning, and then how much hydrochloric acid has been used up as we have continued the reaction. So the thing that we need here to help us is an equation. So we've got sodium carbonate reacting with plus hydrochloric acid, and it's going to give us sodium chloride, carbon dioxide and water. And I need to balance this equation up, so I need to put 2 in front of sodium chloride and I need to put 2 in front of HCl. Now the main things here is the carbon dioxide and hydrochloric acid ratio. So I've got 2 moles of hydrochloric acid to every 1 mole of carbon dioxide. So if I can work out the number of moles of carbon dioxide I've made, then I know I've used twice as much hydrochloric acid. Okay, so first thing I needed to do was to do the equation. The second thing I need to do now is I need to calculate the number of moles of carbon dioxide that I have produced. Now I've got the volume here, so I'm going to have to use the gas equation, PV equals nRT. I need to find the number of moles of gas, so N equals PV over RT. Now I have no moles of gas at the beginning, but I've got no volume of gas at the beginning because the reaction hasn't occurred, but after 15 seconds I've got 140 centimeters cubed of gas. So I'm going to have to work out the number of moles that is. So for 15 seconds, what is N? Well, P is 100,000 pascals. V is in centimeters cubed, that's 140 times 10 to the minus 6 meters cubed, so I transfer it to meters cubed. R is 8.31, and T is, it says it's at room temperature and pressure, so that's at 298. So I just need to substitute that into this equation. So N equals 100,000 pascals times 140 times 10 to the minus 6 divided by 8.31 times 298. Okay, so from the calculation, the number of moles is 5.65 times 10 to the minus 3 moles. Okay, so I can do the same thing again. So that's for 15 seconds. 15 seconds. I can do the same thing again for 30 seconds. N equals 100,000 times, and this time it's 282. 282 times 10 to the minus 6 divided by 8.31 times 298. We can work that out. I'll put that in the calculator later. 45 seconds. N equals 100,000 times 423 times 10 to the minus 6 divided by 8.31 times 298. Again, I'll put that into the calculator and I'll get the answer for that. 60 seconds. N equals 100,000 pascals times, and this time it's 565 centimeters cubed for 565 times 10 to the minus 6 divided by 8.31 times 298, and again I'll calculate that, and then 75 seconds. N equals 100,000 times 682 times 10 to the minus 6 divided by 8.31 times 298. Okay, I'll just do those calculations and put them on here. Okay, so I've done these calculations, and we can see that the number of moles of carbon dioxide is increasing. So 5.65 times 10 to the minus 3, 11.4 times 10 to the minus 3, 17.1 times 10 to the minus 3, 22.8 times 10 to the minus 3, and 27.5 times 10 to the minus 3. Okay, so we've got the amounts of carbon dioxide, so that is going to help us to calculate the moles of HCl. So we'll do that next. So the main thing here is, well, how much acid did we have to begin with? So the third thing we need to do is work that out. Well, we know that we had 500 centimeters cubed of a 2 mole per decimeter cubed solution, and to calculate concentration, so concentration equals moles divided by volume, but we want to work out the number of moles. We do want to work out concentration, but we want to work out the number of moles that we've got in this first. So moles is concentration times volume. So if we want to know the moles of HCl, it's the concentration, which is 2.0, multiplied multiplied by the volume, which is 500 divided by 1,000. 500 divided by 1,000 is a half, so a half times 2 is 1. So that's how many moles of HCl we had at the very beginning of the reaction. So that's our initial quantity, so that's our initial number of moles. Okay, so from the balanced equation we can see that for every 1 mole of carbon dioxide we will need 2 moles of HCl, or we will use 2 moles of HCl. So at the very beginning of the reaction we had the 1 mole of hydrochloric acid. Once the reaction started, the hydrochloric acid was being reduced. So for every 1 mole of carbon dioxide that was produced, we'd used 2 moles of hydrochloric acid. So this is where we come to our calculations here. So for 15 seconds we used, so that's the time, we used 5.65 times 10 to the minus 3 moles times 2 of HCl. For 30 seconds we used 11.4 times 10 to the minus 3 times 2 moles of HCl. For 45 seconds we had 17.1 times 10 to the minus 3 times 2 moles of hydrochloric acid. 60 seconds was 22.8 times 10 to the minus 3 times 2 moles of hydrochloric acid, and 75 seconds was 27.5 times 10 to the minus 3 times 2 moles of hydrochloric acid. So if we do that on the calculator, so 5.65 times 2, so that was 11.3 times 10 to the minus 3 moles, so I'll put moles there, 11.4 times 2, so that's 22.8 times 10 to the minus 3 moles, that's 34.2 times 10 to the minus 3 moles, that's 44, I'll do 2.8 times 2, that's 45.6 times 10 to the minus 3 moles, and 27.5 times 2, that's 55 times 10 to the minus 3 moles of HCl. So that's the HCl. So that's the amount of hydrochloric acid we used up. Okay, so how much hydrochloric acid did we have left? So at 0 time we had 1 mole of hydrochloric acid. At 15 seconds we had 1 mole, take away the amount we used, 11.3 times 10 to the minus 3 moles. I'll work that out in a minute. 30 seconds I had 1, take away 22.8 times 10 to the minus 3. After 45 seconds I've used this amount of hydrochloric acid, so how much have I got left? So it's the initial amount, take away the amount we used, times 10 to the minus 3. 60 seconds is 1.0, take away 45.6 times 10 to the minus 3. And 75 seconds is 1, take away 55 times 10 to the minus 3. Okay, I'll work that out and I'll come back. Okay, so I've calculated the amount of hydrochloric acid I've got left at no seconds before the reaction starts. I've still got 1 mole left. At 15 seconds I've got 0.9887, but if I'm going to take this to 3 decimal figures, that would be 0.989. 30 seconds it's 0.9772, but that would come off. 45 seconds is 0.9658, again to 3 decimal places is 0.966. 60 seconds 0.9544. 75 0.9450. Okay, so that's the amount of hydrochloric acid I've got left. So how do I convert that to concentration? So the fifth step that I have to do, the amount of hydrochloric acid I had, or the volume, was 500 centimeters cubed. Well, that's not going to change over the course of this reaction, so we're going to still say we have got 500 centimeters cubed of hydrochloric acid. So we can work out the concentration. So concentration is, I had it up here, is moles divided by volume. 500 centimeters cubed is 0.5 decimeters cubed. Okay, so we've got the moles here. We just need to divide the moles by the volume. So at the very beginning, at 0, so I'll do it here, so time 0, we have got 1 mole divided by half a decimeter cubed, so 2.0 moles per decimeter cubed, which is what we had at the very beginning. 15 seconds, we have got 0.989 divided by 0.5. I'll work that out in a minute. 30 seconds, I've got, I better just move this up here. So at 30 seconds, I have 0.977 divided by 0.5 equals 45 seconds is 0.966 divided by 0.5. 60 seconds, 0.954 divided by 0.5, and 75 seconds is 0.945 divided by 0.5. Okay, I'll just go ahead and do that calculation and give you the values. Okay, so I've done those calculations. So here's the time period. This is the number of moles divided by the volume, and we get 2 moles. Do you know what? That doesn't look right. I'm just going to give it another go. 0.989 divided by 0.5 equals, I knew that didn't look right, 1.978. Then so the concentration's just gone down a little bit. 1.954, gone down a little bit more, gone down a little bit more. That's what we'd expect because the hydrochloric acid is being used. Okay, so we have this information now, and the next thing that we need to be able to do is to plot a graph. Okay, and we're going to plot a graph of concentration versus time. So concentration versus time. Okay, grab yourself some graph paper and concentration on one axis, time on the other. Okay, so just to recap, always read the question, draw yourself a little diagram so you know what's happening. The first thing you'll need to do is to write a balanced symbol equation. If you've got gas coming off, chances are you will have to use the gas equation, and you'll have to rearrange it for the number of moles. Work out the number of moles of gas that's come off, okay, for each time period, and then what you're going to have to do from there is you're going to have to work out what that means in terms of the hydrochloric acid or the reagent that you used. You'll need the concentration of the acid, so you need to know how many moles of acid you've got in your reaction, and then you can link the carbon dioxide moles to the amount of, or the number of moles of HCl you used by using the stoichiometry of the balanced equation. So we know that we had 2 moles of hydrochloric acid for every 1 mole of carbon dioxide, and so we're able to work out the number of moles of hydrochloric acid that we used. We then converted that hydrochloric acid, and we worked out how much hydrochloric acid was left. So this is HCl that's left, and we've got that there. Because we know the volume, we can work out the concentration of the hydrochloric acid that is left. So we can do that here by doing moles of hydrochloric acid left divided by the volume, and that would give us our moles, and from there we can plot concentration versus time.